Good day guys and welcome to SB Tutorials, and today we shall be talking on system of units, which is the first topic on mechanics statics. So the system of units, the first one we have is the international units. The international units, um, which is also called the system of units, international system of units, which is the SI units. So in here we have units like meter, which has a symbol of M, kilogram, which has a symbol of kg, and seconds, which has a symbol of X. And these are just the three basics SI units we have for now. And the second one we want to look at is derived units. So we are not going to be looking at all of the units. We are just going to be looking at the important ones we need for this course. So the first one we have is force, which has a symbol of N, and it can also be noted that one N, which is one force, is equals to kg times meter per second square. So this is what it's derived from. That's why it's called a derived unit, because 1 Newton is equals to kg into meter per second square. So when you evaluate all these together, you get 1 Newton. So this is what derived unit is all about. So also you can also see from that derived unit that force F is equals to mass, right, times acceleration, because acceleration is equals to meter per second square, which is the unit of acceleration. So also we can break this down to give 1 kg into, then when we talk about acceleration due to gravity, which we all know is 9.81 meter per second square, is going to give us 9.81 Newton. So this will basically mean when we talk about derived units. And also okay, and we're going to be talking about multiplication factors, their prefix and the symbols. So as you can see here, you might already be familiar with some of them here. For example, we have tera, which is equals to 10 raised to power 12, and the symbol right here is represented with T. So the next one we have giga, right, which is 10 raised to power 9, and it has a symbol of G. And mega, kilo, hecto, deca, deci. So these are like the most common and commonly used ones we know. And during the course of this engineering program, um, these are some of the multiplication factors that you will see most of the time. So what does all this means? So we can actually take some examples just to familiarize ourselves with all these multiplication factors. So when we represent a symbol like 1 tera, so what this means is that all you need to do is recall that T is tera, which is equals to 1 times 10 raised to power 12. So in some engineering exams, you might be lucky, they might give you this value, but while some you might not be lucky, they might not give you the value. So that's the more reason you have to know that 1 T represents 1 tera, which is equals to 1 times 10 raised to power 12. Okay, let's do another example. So when you have, for example, they give you 3.85 mega, which is represented with the capital letter M, right? So you're going to have 0.85 times 10 raised to power 6. So M represents mega, which is 10 raised to power 6. So you can easily evaluate it. So 0, 8, 5, 0, 1, 2, 3. So this should be your evaluation for 3.85 mega. Okay, so let's go into more practical example. So what about if we're given like let's say a force of let's say 7.1654 G Newton, right? So when some students actually see this, they are confused in the example because they don't know about multiplication factors. N, first of all, is the unit of force, so you don't need to evaluate this. The only thing you need to do here is to evaluate G, and G here stands for giga, and the multiplication factor is simply times 10 raised to power 9. So that's what it means. Then you can just write the units in front of it. So you can easily evaluate this, or you can just leave it like this in standard form. So your force is actually 7.1654 times 10 raised to the power 9 newtons. Okay, so let's go over to the negative powers. So for example, you can actually use these when you have bigger numbers, like you want to evaluate something like this, like currents. Okay, so let's say you have solved for current value, and you have something like let's see, okay, 0.056 amperes, right? So when you want to evaluate this to standard form, you can actually do this 1, 2, 3. So what this will now mean is that you have 356 times 10 raised to power minus 3 amperes, right? So times 10 raised to power 3 means you can see that times 10 raised to power 3 here has a multiplication factor which is milli, and the symbol is m. So what you can do now is come back here, you write 356 small letter m, then ampere. So in case you are solving for an exam and you don't see this on the options, you can also represent it like this, which might also be in the options. Okay, so that's one example. And also you can also apply this for also the positive powers also, like when you have okay, maybe you calculate a force or energy, rather let's use energy, right? Energy, calculate like 130 joules, and then all you can do is 1, 2, 3, 4, 5, 6, 7, right? You see there's no 7, so you just have to increase it to okay, let's take it down by 6 because we have 6. So 1, 2, 3, 4, 5, 6. Okay, you can represent this as 1, 3, right? 0. So 6 here we have mega, right? So we can see capital letter M, megajoules, or we can take it further to 7, 8, 9, which is the same thing as 0.13 gigajoules. So these are the different ways you can just play around these multiplication factors, and I will advise you to test yourself more on it. Do some examples and then get familiar with it so that when you see it in a problem later in this course, um, it shouldn't give you an issue to resolve. Okay, in this video, we're talking about the US customary units, right? So earlier we talked about the International System of Units, which is the SI units, right? In which we can use to measure different quantities, for example, length, which is measured in meters, right? And also we talked about force. Force is a derived unit, which is measured in newtons, right? And also mass, which is a um, simple SI unit, which is measured in kg, right? So all these are different units we can use to measure different quantities. But for the US customary units, length is measured in foot, right, rather than in meters. So we have a symbol ft, while force is measured in pound as a symbol of ib, and mass is measured in slug, right, in slug. Okay, so that's it for the measurements, the US customary measurements, and also we can look at some factors, conversion factors or rates. 1 feet is equals to 0.3048 meters. Okay, this is very important when we want to convert from feet to meters or from meters to feet. Okay, so for example, we have let's say we wanted to convert like 5 feet to meters. So what you need to do is just note this conversion rate on your head, and then just all you need to do is multiply. So first we want to bring the feet under so that it can cancel out. So 1 feet is equals to 0.3048 meters. And what you need to do now is just to use your calculator. First, so I'm going to type that in right now. 5 times 0.03048. Okay, that's going to give us 1.524, right? So feet is going to cancel out feet, then we're going to have meters. So it's as simple as that, which we can convert from feet to meters and also from meters to feet easily. Let's take another example. For example, I want to convert 382 meters to feet. So what I need to do is write down 382 meters and then use a conversion rate. So we want to put 0.3048 meters at the bottom so that meters can cancel out. Then put 1 feet at the top and then divide. Okay, so when we do this, 382 divided by 0.304, we're going to have 1,253.3 feet. Okay, so that's how we can convert from feet to meters and also from meters to feet. Okay, we also need to take note of acceleration. So acceleration is equals to feet per seconds, right? So for the SI units we had meter per second square. So but this time we're going to be having feet per second square because the meter here is placed with feet for the US customary units. And also acceleration due to gravity, it was 9.81 meter per second square. And for the US customary units, acceleration due to gravity is going to be um, 32.2 feet per second square. Okay, so when you are giving, when you're giving parameters in feet and slug, it's not wise to use um, this value 9.81 as your solution due to gravity. For example, you want to calculate for force, and you're given maybe, for example, mass in 3 slug, right? Or it also uh, you want to calculate for force, then you use 3 times 9.81. So this is wrong, and you're going to get a completely different answer. So the right one you should use is 3 times 32.2 to get your force time, which will give you 32.2, 96.6. So this is going to give you pound, right? So this is the right solution and not this. Okay, also from our formula, we can also try to break down the unit for slug, right? The unit for slug, like from this formula. So we know that this is in pound, right? And m times feet per second square. So mass should be pound all over feet per second square, right? Okay, so we can say that this is the unit for, or rather, this is equals to slug, right? So that's what it basically means. Okay, and also we can also measure length in miles, right? Which has a symbol of mi. Okay, so this can also be used, and also we can also measure length in inches, right? So the symbol is inch, or with an hyphen. I think we double hyphen, right? Then in feet, there's a single hyphen, right? Okay, so when you see something like this, for example, 2 feet and maybe 53 inches, yeah, I think that's it. So you can measure length to be like this, right? So length in maybe the length of a rope, it's 2 feet and 53 inches. Okay, so let's look at some conversion. Okay, so let's look at some conversion uh, rates between miles and feet. Okay, so 1 mile is equals to 5280 feet, right? And also 1 inch, right, is equals to 1/12 of feet, 1/12 of a feet. Okay, so these are some of the conversion factors. Just like the way we applied it year and year, you can also apply this conversion rate when converting from miles to feet, or from or from feet to mile. Okay, and also when you want to convert from inches to feet or from feet to inches. Okay, so another thing I want to talk about also is the kilo pound, right? So when you have 1,000 pounds, this is going to be equal to 1 kip, right? Okay, let me write that again. 1 kip, so KIP. So 1,000 pounds is equals to 1 kip. Okay, we can take some examples. For example, we want to convert 93,000 pounds, right? This is simply going to be 93 kip. Okay, so this is kilo pound and this is just a pound. So it's very simple to convert. And okay, so the last thing I want to talk about is velocity expression, right? So velocity in for the US customary unit is usually expressed in mile per hour, so which is mile per hour, or in feet per second, right? Okay, so for example, we have 30 mile per hour. Okay, we have 30 mile per hour. So what we want to do now, we want to convert this to feet per seconds. So all we need to do is to take a look at the conversion rate. First of all, we want to convert this mile to feet, and we already know the conversion factor. So we want our miles to be on the ground, so on the denominator rather. So we're going to have 1 mile, right? Another 1 mile is equals to 5280 feet, right? So the miles can cancel out. Then we'll be left with feet. Then we want to convert the hours to seconds. So we know we want to bring the hour. So 1 hour is equals to how many seconds? I think 3600 seconds, right? Okay, so hour, get rid of hour. So we'll be left with feet and second at the bottom. So all we need to do now is to evaluate all this, and when we do, we get 44 feet per second. So this is how you can convert from one system of units to another, whether it's the international system of units to the US customary units, and also between units. Okay, so we can also do this for meter per seconds, right? Meters. We know the conversion rates from feet to meters, right? Yes, we do. Just say we want to convert from feet to meters per second. So all we need to do is just to convert this on feet. So we know the conversion rate to be 1 feet, right, is equals to 0.3048 meters. So the feet cancel out, then we'll be left with meter and seconds at bottom. So all we need to do is to evaluate this. So I'm going to type this in: 44 times 0.3048. And we're going to have 13.41 meter per second. So these are, you can see we converted from mile per hours to feet per seconds, and now to meter per second. So this is how you can easily convert from one system of units to another. Thank you for watching this video, and if you haven't subscribed, please make sure to subscribe to get more free videos like this, and thank you for watching.